All right, so I ended up starting a second video, so this is going to be pretty short compared to the other things, so sorry. So we're just going to look at two more examples, and the first thing I'm going to do is note the scale. All right, so this is my time in seconds, it's going up by 1, and this is the height in meters, and this is a quadratic function. Again, this is one of our three shapes, and this models the fall of a diver off of a diving board. So first, a quadratic, before we even do anything else, is actually kind of this, it's actually a full U. So what we're not seeing is this part over here. And the reason why we're not seeing that is because on this side, I have time as negative, and that's not necessary. It's not, time is never negative. And then I don't want this part because, also because the time is not negative. So that's why we're only seeing part of the U. We're only seeing part of the U that makes sense for this problem. So first, before I answer any of these questions, I mark my important points. So first, I mark where it starts. So that's 0, 4. I mark where it ends. So let's go ahead and for now, mark this point. So this might be, let's just estimate and say it's about 5, -6. So that's an estimation. It's not quite that. I also need to mark any turning points. So we're going to mark this one. We'll say this is 1.5. And it's a little bit more than 2. So, I'm going to say it's about 6.2. Or it's a little bit more than 6. And then I also mark any x-intercepts. So here's an x-intercept. Again, an x-intercept is where your graph hits the x-axis. And then my y-intercept where it hits the y-axis, which, as it turns out, was already marked because it's my starting point. So first I'm going to identify the contextual domains. Remember, domain, I want to know what's the smallest x that I wrote and what's the biggest x that I wrote. So if I start to look at all the x's that I wrote down, the smallest x that I wrote is 0, and the biggest x that I wrote is 5. So I could write this, and since it's t for time, I could even put an s in there for seconds. I'll put 0 to 5, but just for good measure, I'm going to write seconds below it. So the domain goes from 0 seconds, where the diver starts, to where we stop, and that's at 5 seconds. So the contextual range, that's my smallest y to my biggest y. So now when I look at my y values, the smallest y that I wrote was -6, and the biggest y that I wrote was 6.2. So I'll go from -6 to 6.2. And this is my height, so I'll put h for height, but then again, I'll just put meters off to the side. So remember, in domain and range, you do want to include the values because these are actual numbers on the graph. We should include them, so I want to underline my inequalities there. So unfortunately, I can't find, oh, here's some white out, but it's going to be white on yellow. I don't want that underlined. And then I want to underline here. So underline your inequalities when you have domain and range. All right, so for what time interval is the graph increasing? So again, I'm going to get these highlighters out, and I want increasing. I'm going to make that be in pink. So where my y values are increasing. And then the next question mentions decreasing. So this is my decreasing part. Okay? All right, so again, we're describing that y is increasing. We're describing that y is decreasing. But when we use our answer, we're going to use the x values. All right? So where is it increasing? Well, it starts at 0. I want to look at my x value, and it stops increasing at 1.5. So I'm going to use t for time. You could also use x. And it starts at 0, and it goes to 1.5 seconds. So in between 0 and 1.5 seconds, the diver is increasing in height. So what does this mean in context? The diver's height is increasing between 0 and 1.5 seconds. All right, now I want to talk about decreasing. So where does it start and where does it end? So it starts at the 1.5 until I get to the bottom where I marked it as about 5. So 1.5, again, I'll put T for time, to 5. And we'll say the diver's height is decreasing from 1.5 to 5 seconds. And again, an increasing and decreasing we won't underline, because up here at the top at 1.5 seconds, the diver's not increasing or decreasing. He's kind of just holding steady for that split second, and then he starts to go back down. So we don't want to include the 1.5, okay? And the same for 0. This is kind of like where it starts, so I'm not including it, because here he's not increasing. He's just kind of standing on the diving board, all right? And then when I get here, he's done decreasing. You know, he's hit the bottom of the pool, which is not very deep for a diver, -6 feet. But that's where we're stopping the dive at. All right, so the last one is not in context. So when I mark my important points, I'm actually going to save the ends, these arrows, for last. So what I'm going to do instead is get my x-intercepts. So there's -6, 0. There is 6, 0. My turning point, we're going to go with right there, and we're going to have it be 0, -9. This also happens to be my y-intercept. And now I'm going to get the arrows. So the arrows means that even though my graph paper has ended, my shape actually has not ended. And when numbers don't end, we say they keep growing or they keep getting smaller. We use infinity. So in all of these, I've done an x and a y value. And so I'm still going to do an x and a y value here. But there will be infinities here. So let me just reminder that x is going left to right. And if numbers keep going right and they never end, we say they're getting bigger. We're going to use infinity. And when they go left and they never end, we're going to use negative infinity. So again, that's for the x-axis. So let's put an x here. When I describe the y-axis and the y-axis goes up or down, so I'm going to put a little y in there. When the numbers go up and never end, we say infinity. And when the numbers go down and never end, we're going to use negative infinity. So what I want to do is think about the direction of this arrow. So first, in the end, is this graph going left or right? And as we go this way, it's going left. So for x, to describe x, that it's going left, I'm going to use negative infinity. And then I want to address y. Is this arrow saying that it's going up or down? And it's going up, so I'm going to use infinity. So I still want to include the endpoints, but since they're arrows, we're going to have infinities there. So when I look at this arrow is going to the right, and it's also going up. So when it goes to the right for x, I want to use infinity. And when it goes up for y, I also want to use infinity. All right? Okay, so let's start with these things. So this is review. Again, we're evaluating our graph, and this is in function notation. So again, this just means if x is -2, I want you to tell me what y is. So this tells me from the center I should go left to -2, and then I'll have to go down to -8 to get my y value. And I'll just put the -8 there, and this is the best way the answer can present itself. When the number's not in parentheses, this is like me saying y is 3, and you're going to tell me what x is. So for y is 3, from the center, it means I need to go up 3. And then afterwards, I can go to the left, but I can also go to the right. So if I go to the left, I'm at x is -7, and if I go to the right, I'm at x is 7. So remember, in the parentheses, that's x. Outside of the parentheses, on the other side of the equal sign, that's y. So do I have a maximum or a minimum? So I actually have a minimum value. It's right here. That's that turning point. And we write it like this. So I have a minimum value of -9, because up or down, it's the lowness, the y value, that's giving it the minimum. And then I want to give it more specific directions. When x is, you could say equal, or you could say at 0. All right, domain. I'm not asking about range, so I'm just asking about domain. So again, domain is what's my smallest y value, what's my biggest y value. So I'm going to stick with the between. like this. And I'm going to look what's the smallest x that I wrote. So there's an x, 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 and what's the biggest x? So the smallest x is actually this negative infinity. And the biggest x is this infinity. So we're going to write that. Now, normally with domain and range, I've told you to underline because those numbers are actually part of the graph, right? But since infinity never ends, I can never like include it. So that's what underlining does. It includes the value. So when I have infinity, I will never actually underline. All right, we've got an increase and a decrease. So I'm going to do my decrease in pink. So again, we're going to look at the graph left to right. There it's decreasing. And then my increase will be in orange. Right there. Okay, so decrease. So I want to look at where did it start the decrease and where did it stop the decrease. So again, I write the x value. So I'll use the between. And it starts with the negative infinity and it goes until 0. All right. The increase starts at the 0 until I get to the infinity. So I'll do my x with the between, and I'll put 0 and I'll put infinity. Now, if you want to, sorry you can't see that, you could actually leave out the infinity signs because this is kind of redundant. But if you kind of like this format, just stick with it. But basically, this is saying that all my answers are between negative infinity and 0, which means if it's in between negative infinity, like here's 0 and here's negative infinity, it's everything smaller than 0. I hope that makes sense because negative infinity never ends. So if I just want to write one thing on this one, I could just say that all the x's are just smaller than 0. That's the whole decreasing, right? And then when I do the increase, instead of saying 0 to infinity, well, it's increasing past 0, greater than 0. So I could just drop the infinity part and put the x on the left side and just say x being greater than 0, like that. And here, just drop this, and you'll see that matches up. But again, if you like this between, and it's always consistently the same, that's how we've done all of those, then stick with that. All right, you will be submitting this page to OneNote. All right, page 10, you need to click on the Chapter 2 tab. And I think what we're going to do is, maybe at this point, I might stop with the video and do the average rate of change with you when I see you in class, because the videos are getting a bit long now and I don't want your whole time consumed with videos. So we will be leaving this part blank and we'll come back and address it when I see you in class this week when we talk about average rate of change. All right? I think that's the plan, or I'll put it in the next week's video. I'm really not quite sure what I'll do, but I'm not going to discuss average rate of change right now. That's it. Thanks, guys.